In this session, for the 8th and 9th grade mathematics, on the topic algebraic indices and laws of exponents, we are also going to see division of monomials, binomials, and trinomials and polynomials. First, let us see the basics, the laws of exponents. A power m into a power n is equal to a power m plus n. This is known as the product rule, the multiplication rule or the product rule of exponents, the indices. Next, we have the division rule, a power m divided by a power n, or a power m by a power n as a rational number, where a is the same base, and we have that is equal to a power m minus n. Then we have the power rule or the exponent rule, where a power m is raised to the power n, whole raised to the power n. Just multiply the two powers, that is the two exponents, a power mn, the product. That is called the power rule. Next, we have the same power but different bases. The rule of the same power but different bases. A power m into b power n, m. M is the common base, common power. So we take it as ab into b, we multiply or even divide. If it is division, it's going to be division. So ab whole power m. The zero index. If you have any number raised to the power 0, it is equal to 1. Negative indices or the reciprocal rule, a power negative m is equal to 1 by a power m, the reciprocal. If you want to make it a positive index or positive power exponent, we have to take its reciprocal and make it positive, and vice versa. Negative to positive and positive to negative exponent rule. This is the reciprocal rule. Then we have negative 1. Any negative number, negative 1, any negative number raised to the power even number, raised to an even number, the power is equal to a positive number. Negative number raised to an odd number, the power of an odd number, is equal to a negative number. So this is an important rule for simplifying. Here we have a few questions for the simplification using the laws of exponents, which could be done easily. For example, I'll just take one of these. G is the same base here. Of course, divided by g power 0 is 1. So the denominator becomes 1. Division by 1. So you just have to do this g power minus 2 plus 3, which is equal to g itself, g power 1. Look at this d subdivision here. M cubed whole cubed into m power minus 2, m power negative 2, whole raised to the power 5. Let us do the brackets first. Let us simplify this using the power rule, multiplication of the powers. M power 9, 3 into 3 is 9, m power 9, into m power minus 10, negative of 10. We are multiplying a negative number by a positive number, minus 2 into 5. So we will get m power minus 10. Now we multiply the 2. M is the same base. So m power 9 plus of minus 10, or 9 minus 10, which is equal to m power minus 1 or m power negative 1, which can be written as 1 by m, the positive exponent, as 1 by m. That's it. Moreover, we have a few more questions like this. Let us go on to the little more complex ones. Here, this A subdivision, simplify the following. P squared into P power minus 5, the whole square. These are two monomials, the multiplication of two monomial expressions, P squared and P power minus 5. What is it? Product rule, of course. Multiplication of two monomials. And we use the laws of exponents here, the multiplication, the product rule. And we can multiply the 2. P power 2 plus of minus 2, 5. It is p power minus 3, negative 3, whole raised to the power 2, whole square. So we multiply the powers. So p power minus 2, minus 3, p power minus 3, the whole square. So just look at that, p power minus 6. By, you have a division here, we have by p power 3. So p power minus 6 minus 3. It is division rule, so negative, you have to minus, we have to subtract the powers. So p power minus 6 minus 3, which is equal to p power minus 9, can be written as 1 by p power 9 as a positive exponent if required. Here again, here is a very tricky one, but we have this b subdivision here. H power 0 is 1. So the denominator becomes 1. So we just have to do the numerator alone. This is very easy because h power and h power. So h power negative 2, h power negative 5. Just add the powers. H power negative 7 and whole raised to the power minus 1. Multiply the powers now. Use the power rule. So h raised to the power negative 7. When you add these two negatives together, you get a negative 7 here. H power negative 7 whole raised to the power negative 1. So multiply the powers, you'll get h power 7 because minus into minus is plus. So h power positive 7. That's all. So there are some other examples which seems to be complicated, but it's very easy. Just you have to multiply the literals first, constants. 2 by 3, here 2 by 3 into minus 9 by 4. Minus 18, here of course minus 18 by, we could also simplify it further. You could try these questions. A squared into, this will be a cubed of course, and b cubed. That's fine, this is easy. Here again, you will be getting the multiplication of the two constants. Two rational numbers here, minus 3 by 7 into minus into minus here becomes plus here. And some can be cancelled and made simple. It's very easy to simplify this. On the whole, you will be getting 2 by 3. After you simplify this, you'll get 2 by 3. You can just do it, work it out. P power 4, p cubed into p. P power 4 into q power 4. That's all. P power 4, q power 4. 2 by 3, p power, you can just verify it. Let's move on to another set of questions. Let us now see how division is done. Here so far we have seen multiplication. Now we're going to see division. Now let us take an example. To divide an expression like this. First of all, in this example we have divide 12 minus 14a squared minus 13a by 3 plus 2a. First of all, we have to arrange the terms in the decreasing order, descending order or decreasing order of the degree, the exponents. Because we have a here, a squared here. So negative, so minus 14a squared. Look at this. It has been from the highest power to the lowest power. 12 means actually a power 0. 12 into a power 0. That's all. So it has been decreasing a power 2, a squared, a power 1, a power 0, like that. So highest power should come first always. So first step is always in any polynomial, if you're given any algebraic expression, first of all, you arrange it in the decreasing order of the exponents of the variables. A is the variable here. So a squared minus 13a plus here, minus 13a plus 12. This is the dividend. Dividend is the what we have to divide. And the divisor is the one which we have to divide by. After by it comes, no, that is the divisor. The divisor here is 3 plus 2a. We have rearranged the terms in the, again, 2a plus 3. We have arranged it in the decreasing order of the powers, exponents. 2a plus 3. This is the first step. Then start dividing. Make this 14a squared minus 14a squared. You have to make that, what is to be multiplied? 2a. You have to multiply by minus negative 7a in order to get negative 14a squared. So negative 7a into 2a gives negative 14a squared. The same sign should come here. You should get the same term, the first term. The next term will be the multiplication of 3 into negative 7a. So we come down to this. We are now, it becomes negative 21a. Because minus here and a plus here. So negative 21a. Now the subtraction takes place with the change of sign. It is always advisable to put the change of sign within the brackets here, unless you forget it. So don't forget to do that. It's quite obvious that we have to subtract and then we have to change the sign and cancel out this 14a squared, minus and plus. Here also we have a minus and a plus. 21 plus 21 minus 13. We give you 8a here. You have to do the subtraction. Get 8a plus, bring down this 12. Bring this 12 down. The next term along with the sign. So plus 12. Now we have 2a plus 3. We have to multiply by a suitable number in order to get 8a, which is nothing but 4. 4 2s are 8. So 8a you get. Then you will get obviously 12. 4 into 3, 12. So the remainder now, after changing the sign and subtracting, we do just adding, of course. Change the sign and add. That's all. Just subtract. That is called multiplicative inverse. Addition, additive inverse, we call. While we add something, when we add, we change the sign and do the subtraction. Now, here we have 0 as the remainder. That means this is exactly divisible, and the quotient on the top here we have, this is called the quotient. So we have 3 things here. The dividend, which is for this one, minus 14a squared minus 13a plus 12. The divisor 2a plus 3, and the quotient negative 7a minus 7a plus 4. This is called the quotient. This is the result. This is the answer. The remainder obviously is 0 here. So that is the remainder. So the division algorithm or the division algorithm statements in an equation form is divisor, this is the divisor, into quotient. This is the thing. So dividend is equal to divisor into quotient plus the remainder. This is how the verification is done. Remainder is 0, the quotient is, this is the answer we get. Now move on to the verification. Here we have dividend is equal to divisor into quotient plus the remainder. Remainder is 0, and we get the dividend back. After doing the manipulation with the divisor, we use the distributive property here. Be careful to do this. 2a we are multiplying by this one, and 3 is multiplied by this, plus 0, of course. And finally, we get this. So we get the value of the dividend to see the verification. Let's move on to another example. Here we have division of algebraic expression, division of a monomial by monomial and polynomial. We are going to see the long division method. This is another example, the similar example. Here again, it is in thing, and here again another example is there. Here x squared term is there. Divide x squared plus 6x plus 8 by x plus 4. See, here we have already it is in descending powers of x. X squared comes first, x term comes next, and x power 0, the constant term comes. So it is no need of arranging. The dividend is already in the descending powers of x. And also the divisor is in the descending powers of x. So we leave it as it is, and we do the long division like this. This is the method of long division. X multiplied by x. First, you have to see this should be the same. So what should be multiplied? We have to multiply by x to get x squared, isn't it? X squared plus 4x. Write it below. Change of the sign. Subtraction means change of sign. And this will get cancelled. 4x minus, 6x minus 4x, 2x. Then bring this 8 down with the sign, plus 8. Now multiply by 2. This is the 2. We get 2x plus 8. We get the remainder as 0. If we do not get the remainder as 0, which means that we get some other remainder. That's it. That's the thing. Okay. Here we get, here also the cubic comes here. So these are the examples of. In the next session, we are going to see how to factorize algebraic expressions. May it be binomial, trinomial, or a polynomial. Okay, then we have seen division. In this video session, we have seen division of, some more examples are here. Some complex examples are over here. You can try them out. This worksheet I will be sending to the students for the benefit of working out. We may have to arrange some terms because arranging the terms is important here. Using long division. Here is a rather a thing that comes out. Some terms are missing here. We can do this by factorizing, but we will see that later in the next session, because we have to do factorizing using identities and other things. Is coming, both coming sessions, we will see that. Using division, using division, show that x minus 1 is a factor. We can do this, provided we have to again see, there are some missing terms. X squared is not there, x is not there. So what we should do, we should not leave it like that. We have to fill the gaps. We have to fill the gap. There is a gap. So 0x squared plus 0 into x minus 1. So we need to put all these things. Then only we will get the exact, the gap will be filled here. X into x squared. You have to multiply by x squared first. Do we get x squared into x? So x cubed here. X squared into x is x cubed minus x squared minus 1 into x squared minus x squared. Change of the sign. Minus x cubed gets cancelled. Minus changes to plus here, and therefore you get an x squared here. Plus 0x, put it there. Bring down this minus 1. Then see whether you are getting x into the next thing. X squared you have to multiply x by x itself. Then only you will get x squared here. And 0, you will get x below the 0x. 0 into x. So this changes to plus. So x minus 1. And the final thing will be put a plus 1 here. So that you multiply x minus 1 by 1, you get x minus 1 itself, and there you will get the remainder 0. You will get the remainder because it gets cancelled out. So we have seen long division method of algebraic expressions in this video session, and hope you understood it. The worksheet on this would be sent to you subsequently. Thanks for watching this video. And that's